Hello and welcome. In the previous video, I've briefly mentioned the new project this channel will be following. I would like to introduce to you what I wish to achieve. Introducing Project CompuSAR. The idea is to build an entire, fully functioning 80s era computer. There are actually several such attempts today, mostly centered around the Commodore 64 machine. Those have two main approaches. One, such as 60Clone, is to replicate the hardware more or less precisely. You buy a newly fabricated, totally compatible PCB, and then you start shopping around for original or compatible parts. Especially for the C64, where Commodore produced a lot of the parts in-house, this might be a very difficult quest. Even when the quest is not difficult, it is typically both expensive and time-consuming. David Murray, better known as the 8-bit guy, recently built a new parts original design Apple I. He says it set him back quite a hefty price, as well as took a very long time to build. The main advantage of this approach is that you get the real deal, down to the interfaces with the original external hardware. The second approach is an emulator. This can be pure software, such as AppleWin, or packaged hardware, such as the C64 Maxi. The pure software ones are definitely nice, but of course interfacing with original hardware is right out of the question. The packaged ones, however, to me represent the worst of all worlds. Not only are they not particularly cheap, they also don't interface with the authentic hardware. Worse, and to me this is a complete deal breaker, they have lag. 8-bit guy actually measured it, and while he finds 3 frames of video delay to be acceptable, I do not, especially not for games. To me, the whole point of the 80s computing experience is the immediacy. Particularly on the Apple II, nothing you did on the computer took particularly long. I realized that the Commodore 64 with its horribly slow disk drive gave a different experience. But watch this. With almost everything the computer needs to know already in the computer's ROM, and everything else needs to load into a mere 48 kilobytes of RAM, boot time is quick if not instantaneous. Compare this with the boot time of the C64 Maxi, where the 8-bit guy measured 19 seconds to cold boot. So what do I suggest? I want something that will be able to run the original software, interface with the original hardware, and be based on modern components. Oh, and I want the same hardware to be more than one computer. At the very minimum, I want the computers that ruled supreme the landscape of my childhood. The Apple II, the Commodore 64, and the Sinclair ZX Spectrum. Maybe even the Amiga as well. But ideally, I would want the platform to support much more options. Turns out, there is basic functionality that can do something like that. It's called an FPGA, or Field Programmable Gate Array. It is a chip that, when manufactured, was not set to any specific functionality. Instead, the chip has a bunch of logic gates and flip-flops. When powered on, it can be fed a sequence of compiled bits called a bit stream or core that tells it how those gates and flip-flops connect to each other. So building a computer should be no more than loading specific bit stream into the FPGA. You want an Apple II? Here's the relevant bit stream. Commodore 64? Here's another, and so on. Let's talk about what I want the end product to look like. Ideally, it should have display, input, keyboard, joystick, possibly mouse, RAM, at least enough for the basics, so 128 kilobyte for the Apple II, plus however much we need for the ROM, storage, expansion pins. I'll explain a little later. This is a Spartan 6 based development board I got from a friend who no longer needs it. It has a Spartan 6 XC6 SLX9 FPGA, 8 megabytes of RAM and VGA and PS2. It checks all of the peripherals we need for our project. It even has an analog, but I'm not sure whether that's input or output. FPGA implement logic gates in LUTs or lookup tables. This one is a little on the small side at around 9,000 lookup tables. Even so, aside from the storage, it has everything we might need for our Apple II replica. We don't know how much it costs, as the company that made it went out of business, but it wasn't expensive, a few tens of dollars. Of course, the Spartan 6 family has been superseded, but I've got a more pressing issue with this approach. The idea with creating such a board is to have it usable to people easily. At this point in time, both PS2 and VGA don't really live up to that aspiration. Modern displays are HDMI or DisplayPort, and modern input devices are USB. If we want something that easily works for modern end users, those are the interfaces we should be aiming for. Alternatively, if we want something that caters to users of the authentic platforms, we should have composite and RGB analog outputs. Either way, VGA isn't it. So my ideal setup as I see it: at least 8 megabytes of RAM, an HDMI port and a composite video out port, at least 2 USB ports. For storage, I was aiming for using SD cards. They are cheap and readily available. Well, I hear you say, if that's such a great idea, how come no one has thought of it before? The answer is, they have. May I introduce to you the Mister. This is a CPU FPGA hybrid built around a standard FPGA development board with an extremely powerful FPGA and a list of supported 80s and 90s as well as some 70s platforms, as long as you could possibly wish for. So with such a cool product already available, why bother with start a new one? For that matter, why do I show you a website rather than the actual product? The answer is, it is expensive. $170 just for the development board itself, which was not built for this purpose. With the I/O boards, the bundle is advertised for $380. While not impossibly expensive, it is not a cheap product by any stretch of the imagination. At best, you can say it is cheaper than buying some of the platforms it is emulating. And I think I can do better. Here's the product I want to be based on: the Spartan 7 entry-level FPGA. At around $20 per chip, it is completely affordable. In fact, this development board by QMTech sells for $30 and contains an HDMI port, 256 megabytes of RAM, and enough flash to hold the FPGA configuration and quite a bit left for extra data. The only thing actually missing to make this a whole computer is USB and an SD card. Now granted, this FPGA is a little on the small side. At 8,000 lookup tables, it in fact has less room than what the Mister takes to implement even the Apple II Plus, which, as I've said before, is an extremely simple computer. The comparison isn't as straightforward because different FPGAs get different bitstream compilers, which generate different efficiency of code, but the cores written for the Mister won't be trivial to transfer to such a platform. I actually have a plan that, at least according to my back-of-envelope calculations, should make it all fit. Even if more logic units are needed, the price of a bigger Spartan 7 chip doesn't climb dramatically. Full disclosure, while I am an experienced embedded programmer, I am not an FPGA developer. This is the first major project of this kind I'm undertaking. Still, even if it crashes and burns, I'm sure I'll learn a lot from it, and hopefully so will you. I mentioned expansion pins before. The idea is to hook as many of the unused FPGA pins to generic expansion ports, and then have platform-specific expansions. Do you want to hook original Apple II joysticks or expansion boards? Let's create an expansion board to do that. How about Commodore 64 cartridges and drives? Again, why not? Not a new concept, but one I'd like to see implemented at a more affordable price point. So this is the challenge I want to place on myself. Can I fit a whole computer on a small FPGA? Or am I just being delusional? I'll talk about design and ideas as well as why I think it's possible on such a small FPGA in my next video.